Hello everyone, my name is Matthew Wilson and this is our introduction to shifters. Today's going to be quite a short lesson. I don't have too much covering this, seeing as we used our previous assignment, C5 muxes, in order to create this assignment. So we're not going to see too much change here, hence why I don't have any slides today. Everything will pretty much just be on Logisim. Uh, Pretty simple lesson, and we'll get into it now. Okay, so our first example here is a shift left or right circuit that I've built. So if you want to go ahead and test this, I like to start out with a simple digit first. So if we want to go ahead and test input 4 here, as you can see, when our output here is 0, our input here is 0, it's going to shift right, as we can see, so our 4 turns into 2. And another good way you can think about this as well is when it shifts right, it divides, and when it shifts left, it multiplies. So 4 is a pretty good number, hence why I started with it. So as you can see here, our 4 turned into a 2 when shifted right. And if we turn this on, it's going to power this left, which will give us a output of 8. And 4 times 2 is 8. And like I stated previously, left you're multiplying, right you're dividing. And if we go ahead and take a look at the internal circuit here, as I said previously, we used our components of our C5 video that I made previously in order to help us out with the circuit. And basically the strategy here, in my opinion, is quite simple. Here, let me go ahead and fix this real fast. Right. Okay. So the way I like to think of this project and this inner workings of this assignment is by thinking to myself, so my input here is on, as we stated previously, 4, or our A2 value here. As you can see, it's highlighted here. And right now we have a shift of going to the left. So the way I like to think about it is kind of following this, and A2 usually would be Q2. But if we go ahead and shift left, it's going to move up to Q3, and that Q3 is going to be our 8. So we have A3, A2, A1, A0 here on our left, and then Q3, Q2, Q1, and Q0, which basically is going to cause this really nice kind of funneling strategy that I like to do. A2 turns into Q3, and vice versa. If we turn this L1 and R0 to 0, shifting it right, it's going to go ahead and put that A2 at Q1. And for our second and final circuit today, we have our shift in 4 different modes here, which, as you can see, again, we used our C5 mux folder here in order to we used our 4.1 muxes in order to create this circuit. If I go ahead and test this, then we'll go ahead and get into the components in a second here. Our test value here is 1001. And we're just going to go ahead and test our 4 different changes here. So our first one would be shift left at 0, 0, which as you can see here is shift left. So this 1 is going to be shifted left, and this one is going to be shifted left. This one will go off, giving us a sum out of 1, and this bit right here will be shifted left, giving us a final result of 0, 0, 1, 0, with a sum out of 0. Our input 0, 1, oh, excuse me, 0, 1 is going to be our no change value. So as you can see, inputs 1, 0, 0, 1. Our directed choice of change is no change, which is 0, 1. And so our output is going to be 1, 0, 0, 1. Our shift right is going to be 1, 0. So as you can see here, this bit right here shifted right, giving us a sum out of 1 and replacing that with a 0. And this bit right here is going to move right as well, giving us a output of 0, 1, 0, 0 with a sum out of 0. And our 1, 1 is going to be our undefined value. And going in and looking at this internally, The same rules follow for the shift left and right. So if we go ahead and just kind of use what we used previously, and those values are going to be 1, 0, 0, 1. Let me go ahead and zoom out here. Right. So with our inputs as 1, 0, 0, 1, we can go ahead and follow the same logic that I explained to you guys in the shift left right. So if we go ahead and do our shift right, which is 1, 0, as you can see, our A0 turns into Q1, and then our A3, excuse me, that would be what? There we go. So as you can see here with our shift right, our A3 will go to Q2, kind of that funneling process of A3 to Q2. And then right here, our A0 will actually be replaced with A0 here because it goes off and will produce a sum out value of 1 and be replaced with A0. And like I said previously, our A3 will be turned into Q2. The main difference between so there's two types of shifts right. One that I did not previously describe, and that is a logical shift right versus a arithmetic shift right. And basically the only difference of that is when a bit shifts right from a logical one, it will always be replaced with a 0. So as you can see here, when we shifted right, this A3 turned into Q2, and the corresponding Q3 was replaced with a 0. Now, with an arithmetic shift right, when this A3 turns into a Q2, it'll be replaced instead with a 0. It'll be replaced with its corresponding bit that was previously entered. So in this example, our A3 would go to Q2, but instead of our Q3 being replaced with a 0, it would be replaced with a 1 because that is what our input was. And finally, these muxes were incredibly useful in terms of creating this assignment, as it gave us the necessary components that we needed in order to create this circuit by giving us our 4 input variables uh, going down and kind of funneling into just one singular output that will be able to be chosen based on our given S1 and S1 or S1 and S0 input values, excuse me. And something I didn't mention previously is that this ground here is used for our logical shift right. And this wire right here is just connected to ground, giving all of these values corresponding with this a input value of 0, so that it will not be affected, and it will just always be replaced with a 0. And thank you, that is all I have.